Okay, so we're going to go ahead and do the application problems now. And so in class, I taught y'all how to do it with the graphing calculator, right, to find intersection points. So here, you're not going to be asked to find the time. So if you guys remember, that's what we used the second trace graph intersect to find, where the t was. But here they're going to give you the time, so basically all you're going to do is just plug in your numbers into your calculator. And so you won't be given your graphing calculator, but you'll be given your little small baby 4-function calculator. Example is going to be very similar to what you have on your review, so if you can knock this one out and understand it, you're golden. So I'm going to go ahead and zoom in because I'm going to do this on this paper. So it says, write the exponential growth or decay equation for each problem. Now if you guys remember, the equation for growth or decay is y equals a1 plus or minus r to the t power. That's what it is for growth or decay. You don't keep the plus or minus. Plus means growth. Minus means decay. You'll have to read the problem and it'll either tell you or you have to figure out whether you're using growth or decay. This was your initial amount, what you start with. Right, here's your rate. Remember, we don't put it in a percentage. If it's in the formula, we have to put it as a decimal. This is your time, and this is your final amount. So that's kind of how our equation works. So it says Alex invests $2,000 in an account that pays 6% annual rate of growth. In 2 years, how much money will Alex have? They first want you to write the equation and then want you to write the answer. So remember, he invests $2,000, so that's his initial amount. So it's going to be y equals 2,000, right? And then in our formula, it says 1. And it says rate of growth, so I'm going to use a plus sign. And then my rate is 6%. But remember, in order to get it from a percentage to a decimal, right, I have 6%. I have to move the decimal back 2 spots. So 1, 2. So it's going to be 0.06. And then it's going to be raised to the t power. That's your final equation. So now they want you to find what, like in 2 years, how much will you have? So I'm going to use the exact same equation. Now 1 plus 0.06 is 1.06. I'm just going to smush it right then and there. And then if it says 2 years is your time, I'm going to put the 2. So in our equation, we just leave it at t because we don't, if I was to ask you 3 years or 4 years, you just leave it in t. But for the answer, they want specifically 2 years. So that's why I'm plugging in 2. Like you said, you don't have a graphing calculator, so how are we going to solve this? So I'm going to go to my handy dandy little smaller calculator. Now looking at our equation, in order of operations, you always want to do the exponent first before you multiply. You guys remember PEMDAS, right? Exponent first. So I'm going to type in 1.06. Now on these calculators, I can't raise it to a power, but it's only twice. So that means 1.06 times 1.06. So I'm going to times it by 1.06 to figure out my answer. Alright, so I get 1.1236. And then the last thing I need to do, so that's the answer to this, I'm going to multiply my answer by 2,000. So I'm going to times it by 2,000. And that's my answer. So this is in money. So my final answer is going to be $2,247.20. There we go. That was my answer. So now let me go to the second one, second problem. It says, how much bacteria will the culture have in 3 days if it starts with 2,000 and decreases at a rate of 93.2% per day? Alright, so same thing. They want to know your starting is 2,000. Usually bacteria is measured in grams. They forgot to put grams, but that's okay. So my starting point is still 2,000. I have 1, and it's going to decrease. So that means it's going to decay. So I have minus. My rate is 93.2%. So I'm going to move the decimal back twice. So you get 0.932, right? And then it's raised to the t power for your time. And now they want us to solve, so 3 days. So my equation is going to be 2,000 1 minus 0.932 to the third power. Alright, so same thing. I'm going to do the inside first. So I'm going to grab my handy dandy calculator. I'm going to do 1 minus 0.932. And this part right here is 0.068. So this is 0.068. So I need to cube that. So I need to multiply it by 3 times. So I have this times 0.068 times 0.068. So I did that twice, right? Because the first time it's 0.068 times 0.068 times 0.068. So I get that big number, and then I'm going to multiply it by 2,000. And so you get 0.6288. So my answer is going to be 0.62 and then grams of bacteria, which makes sense because it decayed, so the number should be smaller than what you started with.